So now you may be thinking, well, Jordan, you put your rectangle horizontally. What happens if I put it vertically? Well, let's talk about that. I'll start by saying something I think you'll find useful. Notice that my rectangle is parallel to my axis. In that case, the shape that I get, when I take this guy and rotate it about the axis, the shape that I get is cylindrical shells. So that's worth writing down. Let's write that down. This is good for your notes. Rectangle parallel to axis implies cylindrical shells. And if you have rectangle perpendicular, if it's perpendicular to axis, that will give you washers. Or discs if you don't have a hole in your washer. Okay, so this is useful to remember. You can see it here. Rectangle parallel to the axis. When I rotate, the shape I get is a cylindrical shell. Now let's do this whole thing all over again. And let's use washers. See what happens. Maybe I'll leave my final integral. I'll leave this guy over here. Now, washers. I will draw my rectangle vertically this time. Draw it vertically. Now I got a chunk of, this little chunk up here is a chunk that is horizontal, delta x. Now I want you to take a second and mentally rotate this about the axis down here. Hopefully you're seeing a washer this time. What's this point right here? This point is the point. Well, we're going to say x is our x value. And then the y component is just given by the function x squared plus 2. All right, washers. How do we do washers again? Oh yeah. We want the integral from, well, it's because I noticed this, I got delta x here. I'm going to have an integral dx, right? So as I go through this region, my x values range from 0 to 2. 0 to 2. And then the formula is what? Pi r outer squared minus r inner squared dx. Now what's my outer radius? Well, the outer radius is this big one all the way from y equals 6 up here, all the way down to y equals -2 down here. So that's a fixed 8. Oh, I lost a piece of my integral here. So outer radius is fixed, is 8. The inner radius is not fixed. Let's draw a horizontal line across, horizontal dotted line from the base of my rectangle out here. Now what is that inner radius? RI. What's that? Okay, I'm going to think of it as a sum of two things. It's going to be this guy plus this guy. And this second guy here, right here, is 2. It's a fixed 2 right there. But this upper guy is merely the y component of this point over here. So the inner radius is x squared plus 2. And I can construct my integral now. So I go from 0 to 2. Pi. Outer radius was 8 squared minus inner radius. Now I'm, oops, I screwed up. It's the sum here, right? This 2 is wrong. So again, the inner radius is this guy plus this guy. So I should have an x squared plus 4 over here. Attention. And we square that, throw a dx on the end. And there we have it, done in terms of washers. And if you're looking for some exercise, you can check that this integral and this integral give the same result.